about the same time. If you haven't already, go ahead and find the Zoom group chat as always and say hello. Let me know you found that chat. As always, we'll be relying on that chat to make sure we can get some good participation. That'll be your place to step in and ask some questions if you haven't had a chance to attend a live show just yet. And it also helps me to know if I should keep exploring a topic in more depth or to move on. It helps me kind of gauge where everyone's at so we can make the best use of our time. Gary said, hello world. Hello, Gary. How about the presentation? Is everyone able to see that on full screen? You should see live webinar, last class before the April PE exam. Awesome. Lots of yeses in the chat. Okay, good. So I've got something new we're going to try today. It was a toss-up between answering a couple of the questions that I've had in my inbox versus maybe covering a couple of other topics. But when I really sat and thought about it, the hardest questions that we can prepare for are those qualitative ones, right? Because there's just an abundance of questions that could be asked about any given subject that doesn't matter how good our math is, we can't really derive our way out of it if we just really don't know the fundamental nuts and bolts of a particular machine or something like that. So what I actually have loaded up on this slide right here underneath it is I have the exam specs, and I went ahead and I calculated how many questions per category. And what I figure we'll do for tonight is just go from top to bottom and pretty much just openly discuss theory. It'll be your chance to step in, ask any kind of questions. I won't be solving any questions live when we go through this. We'll mostly just be talking about maybe things to expect, things to look out for, that kind of stuff. If we have time at the end, I could solve a couple live questions. I'm not trying to not do that, but I really want to focus on the theory and the qualitative aspect and kind of just those fundamental understandings that sometimes help us piece together the bigger picture. And so far, we've done an absolutely fantastic job at solving problems and using the relationships correctly. And it's amazing how far along everyone has come. So I'm really pleased with that. But I think this will be a really good chance to kind of just peek behind the curtain for each of these topics. So we'll do that for a bit. I do apologize for those of you that I haven't been able to respond on emails. It always happens this time in the exam cycle. The last couple of days, pretty much anyone that has any last minute questions, my inbox just gets flooded. And then the students that want to kind of monopolize my time so they can kind of guarantee access to me will book private sessions. And it gets to the point where I have quite literally overlapping sessions. So it gets to the point where I almost sometimes have to turn my inbox off just so I can focus on the live session. So if you weren't able to book a live sessions before they got filled up, sorry about that. There's unfortunately just one of me at this time. So I don't have anyone else that could step in. And for those of you that if I haven't gotten to yet, I'm probably not going to be able to, so I do apologize. The good news is just about, I would say 90% of the questions I'm still getting over the last few days when I do have the chance to skim through them briefly. It's all the majority of things that we've already talked about. So the good news there is the live classes that have already been recorded. If you haven't watched them, it's under the bonus material of the course right at the top. And you can actually watch them in double speed. So if you're already, Jonathan, you make me laugh. If you're already familiar with what's on the video and you're just trying to refresh or revisit maybe that missing piece, I definitely recommend the double speed, especially if you're still trying to cram last minute. It'll save you some time. And then also each one of those tabs with the recorded sessions, it has I took extra time to really make sure I had the agenda in there. That way you know exactly what's in each video and you're not kind of wasting time just digging for information, right? Because no one wants to do that. So I highly encourage you guys to just skim those agendas. And if there are areas where you're unsure of for those topics, that'll be a great place to look. The next thing is the majority of the questions I'm getting, yes, they are. It's typically stuff we've covered, but the good news about that, what I like seeing that, believe it or not, that's actually a good sign. Typically at the beginning of every exam cycle, all of the questions are over every single topic, which is understandable, right? That early on, we're very unfamiliar with the topics. But towards the end, when I'm seeing like really detailed and nuanced questions and very, very, very particular aspects of a problem, and I'm seeing that same pattern, it's a good sign because it means everyone's feeling really comfortable in all the other areas. So before we begin, the same kind of caution that I sent in the update email is this close to the exam. We're not even a full 2 days away, right? We're about a day and a half, maybe even less. I would really caution you against trying to use a lot of your precious time left, really chasing after those last couple of questions. And all of us are engineers. So by very nature and by experience, we're problem solvers, which means it makes us uncomfortable when we don't fully know something. But really avoid that temptation because believe it or not, if you haven't got it now, it's chances are you just don't have enough time for those really particular areas. And the good news is that's perfectly okay because those particular areas, the chances of them showing up on the exam are a lot slimmer when we kind of deviate from the larger volume of problems. So your time is much, 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 much better spent towards getting organized, taking it easy, and all the other things you guys probably don't want to hear. But it's really the truth, and I know it's common sense, but common sense isn't always that common. Especially if you're feeling nervous, if you're anxious, feeling overwhelmed. Those are all great indicators to actually slow yourself down because this close to the exam, the number one thing you want to do is you want to make sure you're feeling your best when you take it. The better you feel, the better you're going to perform, right? It's just like sports. I'm not sure how many of you play sports or played sports in the past, or maybe play instruments or perform in any kind of fashion. But even, on a standard workday, the better you feel, right? Naturally, the better you're going to perform in any setting. So this close to the exam, if you're feeling anxious, that's perfectly understandable given the weight of the exam, given how much time you've spent into it. But now is definitely the time to kind of take a deep breath, take a step back, and you'll probably find it's even kind of therapeutic to go through all of your old practice problems. If you're not organized yet, it's a great place to start, right? You don't want to be staying up into the late hours of tomorrow night trying to get organized. Definitely have your study binder ready to go. Every practice problem you've done, if it's got 3 holes on that paper, put it in your study binder. You should have it organized in some kind of method that works for you, whether it matches the same formatting of the exam specs or whether you group them in categories that make sense to you, as long as you have them organized. So if you get a similar problem on the exam and you get that light bulb that goes, oh, I've solved this problem, I'm pretty sure I've got this in my study binder, I just need to find it. So I might pass up on this, and then on the next pass, as soon as I see it, I'm going to find that practice problem I did in the past, right? That's kind of the in the moment, we'll call it the tactical approach. But of course, that doesn't work if you're not organized and if you don't know what you got. So definitely go through all the problems you've done. The exam is so broad that chances are there's going to be plenty of problems that you solved successfully in the past when you had, a 4-hour, 8-hour study session all the time in the world. But maybe it's one of the earlier topics. But after going through all that material, if you don't give yourself the chance to revisit that, if you wait until the exam to see it for the next time, chances are it's going to jog your memory in a bad way. So I highly encourage you. And surprisingly, not a lot of people do this, and not a lot of people take this advice. But if you're thinking about it, if you're not sure, I cannot encourage you enough to quite literally go flip page by page and just trace it with your eyes, work the problem out in your head, follow your own work. You'll be amazed you'll recognize the handwriting as your own, but you'll be amazed that there's going to be a lot of those problems that you knew how to solve in the moment, that the relationships and the know-how of how to solve them, have escaped you. So that's one of the biggest things I can suggest. And everything else, of course, leading up to the exam, you guys know what to do. Just have everything ready and be ready to go. So before we get started, I'll go ahead and I'll pause and I'll take a deep breath and a sip of my hot beverage here. And I'll let you guys go ahead, ask any question you want regarding what we're going to cover tonight, or anything that I'm talking about here, or any questions. Feel free to ask it in the chat, and we'll answer a couple before we get started. Miguel asked, the presentation looks out of focus. Is it on my computer? Does everyone else see this okay? It looks fine too. So Carlos says it's fuzzy on his. Actually, you know what? I tried a setting to optimize the recording for full screen. The guys that are saying it's blurry, let me turn that off and see if does that look better now? It does look better. Good. Okay, then I know not to do that. I noticed in the recording, the presentation doesn't always take up the big window. I've got a really large monitor here at home. So what that probably did is it probably stretched it or scrunched it to fit yours. But okay, good. I'm glad you pointed that out. Would have hated to carry on for the whole point like that. Jonathan said, just a note, be sure to print your test entrance and read over the examinee guideline. Great point. I hope everyone saw that in chat from Jonathan. Yes, definitely print out your test entrance, right? If you don't have it, they might not let you in. And yes, it will definitely answer a lot of questions for test day, such as what to bring, what not to bring, similar to what we've talked about in the past. So definitely want to print that stuff out and have it ready to go the night before. You don't want to have to make any decisions in the morning, except when you answer that first question, right? You want to limit as much decision fatigue as you can. All right, anyone else? Any more questions before we get started? Omar asked, Zach, if an individual topic, if my performance is not good, like protection, for example, will that affect the whole result? So that's a good question. And that's kind of why I'm cautioning everyone from getting attached to a particular area at the very end if you're struggling a little bit. Remember that we've got 80 questions total, right? 40 in the morning and 40 in the afternoon. And for those of you that are repeat and you've got that exam diagnostics before, in fact, I might even be able to pull up a blank one, but essentially it kind of shows how the scores are broken down. Omar, so to answer you directly, and I'll even scroll down here and we'll look at protection. So protection itself is one of the major 10 categories, right? We've got 10 of the major categories. It's broken down by 4 of the highest categories, right? And then we've got 10 of the major topics, which are in red here, numbered. And then the numbers here, those are the 45 individual, the really subtopics. So Omar, since protection is a total of 8 questions that's going to come here, Omar, if you hit a home run on everything else and you get every question wrong in protection, that's still going to give you 70 out of 80, right? If I punch that in my calculator, 70 out of 80 is an 87.5%. So that's like a high B. Chances are that you're going to pass, right? They don't publish the passing rate, but I've never seen a rate that high from a repeat taker. So did that answer your question, Omar? Catherine said, don't bring your cell phone. Last year, a few people got kicked out of the exam. Yeah, definitely leave in your car, leave in your hotel room. I've heard a lot of stories how they'll make you, if you did bring it, they'll have a table outside the room where you can put a note on it, but they want to see you take it and put it on the table. And there's no security whatsoever. So I don't know about you guys, but I definitely wouldn't feel comfortable leaving my phone out like that. Definitely turn it off. Whatever you do, do not have the device in your pocket on accident, because if it makes noise, they're probably going to kick you out. So be very careful. No Fitbits, no Apple Watches, no smart electronics. There was a story, I think, in Delaware. I want to say it was the last October 2016 exam, where I'm fairly confident someone got kicked out for having, it was either an Apple smartwatch or a Fitbit. It was just like an activity tracker. So just be careful. If you're not sure and you don't need it, leave it in your car. Just be real careful. What else? What other questions? Let me scroll up. Jonathan said, I'm also bringing a pad to sit on. The MD chairs are okay, but could be more comfortable. That's pretty funny. That's a first. That's actually pretty smart, to be honest, but never heard of anyone doing that before. Keena asked, how about the National Electrical Safety Code? Do they ask 2 questions or 1? Okay, good question, Keena. We'll when we're done taking questions right now in the intro, we'll hit that when we work our way down, and we'll definitely talk about that. So Kahina, when we get to the National Electrical Safety Code, if I don't ask your question, or if you have more questions when we get there, feel free to jump right on in. Sarb asked, any idea, Zach, why the pass rate on the NCEES website for repeat takes is so low? Swarb, I would have to take a stab at it, and so I'll give you my opinion. So let me just preface it by saying it's an opinion, because a lot of people might not like it, but maybe it's so low because the majority of people that failed the first time did so because they had poor study habits, and maybe they didn't correct those study habits, or maybe they weren't putting in enough effort the first time, and the second time they also didn't rectify the issue of not putting in enough effort. So I would have to just guess and take a stab at it that it would be some kind of repeat and pattern of that unsuccessful student mindset that we talked about. What else? Jonathan said, no Fitbits either, auto fail. Yep, be very careful. Bring a mechanical watch if you're not sure. But definitely everyone bring a watch. That's for sure. All right, good questions. Any other questions before we start? And all we're going to be doing is we're just going to go from top to bottom, and we'll talk about the number of questions in each category, and we'll briefly discuss the individual subcategories. And we're going to talk about kind of the things to look out for, and if we can, kind of work on our fundamental understandings. And we've also talked about what references are good for each one too. Any more questions? I'll give it a couple more moments and take another sip of my beverage here. And then if there's no more, we'll get started. All right. So the first major topic is general power engineering, right? Makes up 30%. But general power engineering is broken down by measurement and instrumentation, special apps, and codes and standards. And of course, each of these have their own individual the subcategories. Now, if you're not feeling very strong in one of the very individual subcategories, it's okay to not feel very good about maybe 2 or 3 of them. But you still want to make sure that, we'll say, the medium hierarchy topics, A, B, and C's, you want to make sure you're comfortable with at least the majority of them in total. So measurement and instrumentation, you can expect to see, instrument transformers, CTs and PTs all day, right? PT is a potential transformer. It's no different than a voltage transformer. They just typically call it a PT when we're dealing with instrumentation. CTs act just like a voltage transformer, right? Except this time we're focused on stepping the current down. The whole point of stepping the current down for CT is, of course, we use really sensitive electronic relays when we meter, right? When we measure our voltage and our current and all that good stuff. Say we had a transmission line of 230 or 220 kV, we can't just connect that directly to a measurement relay, right? It'd explode, it'd blow up. It's not rated to handle that high voltage. So the whole point of instrument transformers almost always is we're stepping down those values to a value that our equipment can handle, right? And then our relays themselves, when they're telling us, okay, I'm seeing 220 volts here, or I'm measuring, 550 amps. What they're really doing is they're using whatever the built-in transformer ratio is. They're using that ratio to multiply whatever the true reading is, and then they're giving you essentially the extrapolated value, or the value that's on the line. So it's pretty interesting. CTs, they call them donuts sometimes. Good safety question for current transformers. Can anyone, Aaron, you and I are on the same page. Aaron just brought that exact point up in the chat. And I was going to ask if someone can help me to see who knows it. So Aaron, why don't you touch on it? And I'll go ahead, I'll read it out loud for the folks that are going to watch this afterwards. But what are the safety concerns of a CT on the secondary side? And anyone else too, feel free to jump in. So who knows I'll even draw a little diagram here. Maybe it'll help it stick. But essentially, when we have a CT, Bo said, do not open the secondary side. Very true. Exactly. CTs are shorted. Well, they should be shorted on the secondary side. So if this is our transmission line and we've got our amps flowing through it, and then we'll use red. Here's our current transformer. And then here, this circle would denote the relay. So that's just a symbol, right? What the CT really looks like is something like this. Here would be the physical shell, what they kind of refer to as the donut. And then our wires, of course, kind of get wrapped around like this. So this same line right here, that's what's going to go through that donut. Like that. So Jonathan Sisko said, CTs act as a current source. So an open circuit will cause nearly an infinite voltage. Since the CT will raise the voltage in order to keep the current, it will eventually arc in order to push that rated current. Big safety hazard and can almost be instantaneous, so there's no going back. Exactly. That is a textbook answer. So for those of you that aren't sure, so if here's our line current, right? We've got a current going here, and our step down current, our secondary, going to our relay equipment, going to our R. If we open these windings, right, what do we have? What is the impedance of an open circuit? That's essentially an infinite impedance, right? And if we look at Ohm's law, right, where we always start if we're not sure what to do, V is directly proportional to Z. So as soon as we have an infinite impedance, our voltage on that secondary side is going to shoot up because this current on the primary is inducing, right, a source on the secondary. So it's essentially going to arc between both contacts. That infinite impedance is going to ramp up the secondary voltage so fast that it's going to exceed the impedance air gap. And it's going to cause essentially just a really big bang. It's a very big safety hazard. It's not fun for those of you that have seen it in real life. That's why they'll say always short the terminal. So example, if our relay was right here like it should be, let's redraw that like this. This is our relay terminals. A lot of times there's like a test switch, or you can use a jumper. And before, say this relay went bad and we had to change out that relay with a new one, before we could disconnect our terminals on our relay, we would have to close this test switch and effectively short our CT. And then we can go ahead and we can remove that relay. And guess what? Even though we've got an open on this side, all of our current is still flowing through that short, that jumper. Michael Cook asks, why doesn't this happen to the open secondary on a regular transformers? Essentially because the CTs are stepping down the current. Um, that's a really good question. I'm trying to think of the best way to explain it, but essentially when you've got okay, I've got a great way to explain this. So when that's a really good question too. I've never been asked that. The question was, why is that a safety concern for CT and not a PT? Let me go ahead and just make a brand new page. Okay, so here's our CT. Why does that not happen on a PT or a voltage transformer? So here's a regular power transformer. So if this is a three-phase system, that transformer, if we were to draw it out, would look like that, right? We'll draw one phase of it just to represent it. So if this is open, who can tell me what my secondary current is? Who can tell me if I have a PT or a voltage transformer, what's my secondary current if this is open? It's 0, right? Now, on my CT right here, even though I have an open circuit, so we know current cannot exist on an open circuit, right? However, A ratio is I2 over I1, right? So I2, our secondary, equals A times I1. Even though this is open, what's my primary current? My primary current is whatever's being pulled on that line, right? If I had a CT right here on this same three-phase system, if I had a CT right here off to the side, what would my primary current be? It's going to be, our primary current for both transformers is going to be whatever's on this line, right? And our CT, the way it's built, the secondary current going down is going to be a product of this relationship. And so even though it's open, it's still attempting to drive our I2 as a factor of I1. And so here, our secondary current is practically 0, right? Because this transformer, if there's no load on this transformer, what's our secondary? Our secondary is 0. Does that make sense? And even though this still does hold up, right? A is still going to equal to I2 over I1 for this transformer, right? Because a transformer is a transformer. It's essentially just the configuration. It's a really good question though. I'm going to look into that later to have a better answer. But I hope did this answer your question? Who asked that? Michael. Michael, did this help kind of answer your question? Best way to think of a CT, right? CT stands for current transformer. So we're essentially using this line would be like a single winding, right? That's essentially one of the coils. We're stepping down that current that's on the line. Whereas our transformer, PT and our voltage, right? This is voltage. So now we're either stepping or up or down our voltage, even though this still applies, right? All right, great question. These are exactly the kind of things I was hoping for. All right, let me erase this. What else can we talk about for measurement and instrumentation? Watt meters. Watt meters can be very tricky. At the very least, regardless of your comfort level, with actually solving a full question with numbers, you should be familiar with what happens at different power factors. So, for example, if we have a 2 watt meter method, which means it's a 3-wire system, right? We always need at least one less watt meter than the number of wires. So we have our total power is going to equal to the power from watt meter 1 plus the power from watt meter 2. And these end up being the voltage times the current, depending on how they're hooked up, times a cosine of our impedance angle. One's going to be plus 30, and the other watt meter is going to be minus 30. So this theta right here, that's still our theta S or theta Z, however you want to think about it. That's still our power factor angle of the system. Depending on what the power factor is, since we're essentially phase shifting by plus 30 and minus 30, the phase shift already, depending on what this value is, we're either going to get 0, we're going to get 1, right? Because how about this? Cosine of 90 degrees, off the top of my head, I know that's what? That's 0, right? Because cosine is a vertical line, and our x is at 0. And we also know that the cosine of 0 would be right here, so that would be 1. Just so you can type that in your calculator if you're not comfortable doing it the way I did. It's just the way I remember doing it. But so if cosine 90 is 0 and cosine 0 is 1, right? If theta plus 30 is 90, then this whole thing is going to be 0, won't it? What if what if theta minus 30 equals to 1, right? So what if our angle was 31? I'm sorry, what if it was 0? Excuse me. Sorry, I don't mean to keep confusing one. If our angle was 30, right? So this would be the cosine of 30 minus 30. It would be the cosine of 0. Then this entire term is just going to be V times I. I think I updated the table in that module too, but at the very least, just be familiar with how to do that. When you see it worked out, it makes a lot more sense. VOM metering is pretty straightforward. Stands for volt ohm metering. It's hard to it's such a basic concept. Essentially, this is like in the industry, this would be your flukes, any kind of handheld meter. Off the top of my head, who can tell me if I want to measure current and I want to measure voltage? There's 2 distinctly different ways I have to hook up my meters to it. And the hint is a watt meter, because a watt meter is composed of an amp meter and a voltmeter, and it demonstrates that clearly. But essentially, if I want to measure my current on a line, I have to break that line and put it in series with my meter. So here's my amp meter, right? I have to put it in series. You cannot connect something across to measure amps, right? That will not work. That's only for voltage, right? So if I want to measure voltage, that's perfectly okay. If I have 2 points on a system, I connect across them with my voltmeter, and that'll tell me the voltage drop from this point to this point. So those are 2 really good questions to know. What else? Insulation testing, pretty straightforward. A couple of really good videos on the course, just all about the essentially looking for insulation breakdown, right? Ground resistance testing. I like to stress all things grounding. For whatever reason, they just tend to be hot topics. Grounding, it's so related to safety that it seems like that's often tested on in anything. So grounding is really important. Ground resistance testing, I don't know the number off the top of my head, and I believe it's in the NEC, but I could be wrong. But essentially, you're looking for a minimum ohm value. Michael Cook said 25 ohms. Awesome. Keena also said 25 ohms. You guys are on point. So you want to have less than 25 ohms to ground, right? When you're doing ground resistance testing. Yep, good. Heidi said, I'm guessing that's Eric again. Eric said 25 for residential and 5 for industrial. That's good to know too. So residential and less than 5 for industrial. So not a whole lot to really talk about VOM metering and ground resistance testing. Really, there isn't a whole lot to insulation testing either. So expect to see a couple of CTs in one form or another. If you see a PT, say we've got a 3-phase system, you might see it like this. Here's our relay. So this PT right here would be measuring. So if this was a 3-phase transmission line, who can tell me, would I be reading line voltage or phase voltage? What would this, so if this is my PT and my PT steps it down to a factor of the ratio, line voltage, exactly. Perfect. And then you treat it like a standard transformer. Good. All right. What else? So that's about six. That's only about 6 questions. Special apps, lighting and surge protection. A lot of really good books out there. I have good references on that. The Chimera book, actually, that I'm personally not the biggest fan of, but Chimera does a really good job on lighting. And I think Graphio touches on lighting quite a bit too. Reliability is a really interesting concept. Reliability is kind of like the odd man out on all the topics they test on. I'd be familiar with probability in general. Is typically any kind of reliability book you pick up talks about probability. Classic questions like, what's the total combination of, if I have a 52 standard playing deck, right, like a deck of cards, how many combinations can I make out of a 5-card hand? Or, if I've got a die that has 1 through 6 on it, what are the odds of rolling XYZ number? That probability in general, right? Because they could essentially give you a problem if a motor fails X amount of time. What's the probability? So I would just be familiar with probability in general. There are some keywords and buzzwords to reliability, but specifically, if you get any kind of theory question on the practice of reliability itself, just remember that reliability is focused around the maintenance world. If you're working in an industrial plant, if you're working on an oil rig, right, you're looking at increasing the life of your assets. You're looking at, if you do have an asset that breaks, you're looking to decrease the time it takes to repair it, right? Because the longer it takes to repair, the longer that asset's down and it's not producing. You're looking at reducing the cost of parts. It's all about the economics of running a facility. So keep that in mind when you're answering anything with reliability. I find that tends to help. Illumination engineering. Actually, that's what I meant up here. This is lightning. Illumination engineering, Graphio and Chimera are really good. Just very, very, very basic formulas. Be familiar with lumens. Be familiar with Kelvin, right? What are these things measuring? How do we calculate them? Are really good. These are just some of the most basics. Maybe I think it's lumen per square feet or candela per square feet is a really good one. That tends to show in the architectural engineering world when they're planning for like an office building. Demand and energy management calculations. So this is pretty straightforward. I would be familiar with who knows it off the top of their head, or who has another browser tab open and can look up what's the conversion from horsepower to watts. I think it's like 700 and something. Carlos said 746. Okay. So it's 1 horsepower equals 746 watts. Is that right? Yes. Good. Okay. So if you are given, typically they give power in price, dollar per kilowatt, right? If you're given the characteristics of a motor of a machine, you might have to look at the NEC to get the full amps, or if you're given the horsepower, then you should be able to go straight to watts, right? So if we know, we'll say it's 60 cents per kilowatt, and say we've got a total of like let's say three kilowatts, right? Then our kilowatts cancel, and then our price is just going to be, and I'm sorry, this would be 60 cents per kilowatt hour. Yep, Craig got me at the same time. Perfect. So when we cancel our kilowatts, we end up with what? Well, we would just end up with 60 cents times 3, whatever that comes out to, per hour. So that's a really good one. I'm trying to think. These tend to be pretty basic too. Aaron said also calculating kilowatt hour, like for house running 75% loaded for 1 hour and 50% loaded for another hour. What's the total kilowatt hour? That's a good question too. So if they give you how much percent it's running and you know the total load, well, then you can just add them up as fractions, right? If you know So if my total load is, say, 1200 kW, and if it's running for 3 hours at 50%, and it's running at 2 hours at 75%, well, then we can just take that as a fraction of our total. So this is our total. Then I've got 3 hours times 1200 kilowatts times 50% plus 2 hours at 1200 kilowatts times 75%, right? That'll give us our total kilowatt hours. And then from there, we just go straight to dollars, right? If we know the kilowatt per hour dollar amount. What else? Don't forget that. Why is power factor so important? And this is where power factor comes into play. So here's our power, right? Here's our volt amps. Here's our watts. Here's our VARs. So watts are going to do the work we need, right? It's going to transform energy and electrical energy into something we use. It's going to be the force behind our rotor moving in a motor. It's going to be our lamps burning when we turn on our lights. But we're really not paying for watts, are we? We're actually paying for what? We're paying for the total amount of apparent power, right? Which is why power factor is so important. So you might see something like a power factor penalty is how it's usually shown on the bill, because since they charge per kilowatt hour, right? Well, they need to take into account your power factor to find out what you're actually running. So if you have a power factor penalty of X dollars amount, right? If they give you the angle or they give you the power factor, well, you can calculate your total power by what? Your power in watts divided by your power factor, right? What else? Engineering economics, that's one of these special apps. Those tend to be very easy as long as you're familiar with all the cash flow diagrams. Know how to go from present worth to future worth, know how to go from future to equivalent annual payments, know your gradients. Expect to see one or two of engineering economics. Don't be afraid of them. The best bet is you want to be working in years, right? If an industrial plant buys a motor for $20,000 and they own the motor for 5 years, and they're asking for the annual equivalent or anything, you want this to be in years, right? You want each of these periods to be in years. Then you don't have to worry about the interest. Whatever interest they give you, you're good to go. However, if they say you bought a motor for $20,000 and now you're making, if it's compounding monthly, anytime you see that keyword of compounding, you need to know how often it's compounding, right? If it's compounding yearly and you're in years, you are good to go. However, if it's compounding monthly, and these are in terms of months, then your interest rate, say it was 10%, you've got to divide it by the amount it's compounding. So if we're compounding monthly, right, that's 12 times in 1 year. That's going to change your interest rate quite a bit. So essentially, you want your compounding to equal your payment periods. And hopefully that's all yearly. If it's all yearly, which tends to be the simpler problems, then you're good to go. Whatever interest they give you, you can put it directly into whatever formula you need to use. You can put it right here as a decimal amount. But if you're compounding less than a year, what if you're compounding semi-annually, and but you had annual payments, right? You would have your interest divided by 2. So just be aware of that. It's an easy way to trick people that don't know engineering economics, but if you've got a strong handle on engineering economics, you should be able to see it a mile away. Careful, Swab. Just to reiterate, there is absolutely zero talking about past exam questions. If anyone does talk about past exam questions, I'll have to boot you immediately. It's a violation of the NCEES agreement that you'll agree to, and it's a violation of my terms of service. It puts me in a very risky situation. So unfortunately, we cannot talk about previous exam questions. All right, what else? Talked about engineering economics. So 8 questions total here out of special apps. These are pretty easy, right? Engineering economics are a little foreign, but they're easy. Demand and energy calcs, those should be a no-brainer for everyone here. It's just straight math. Illumination engineering, you've got to know the right formula to use. Lightning and surge protectors. Who can tell me what's one of the main components in a surge protector? How does it work? It's a great theory question. Go ahead, tell me directly in the chat. What's the main component? If you don't know, that's fine too. All right, seeing a couple of different answers here. Porcelain, arrestor, insulator, porcelain, oxide. All right, Michael, closer to what I'm looking for. So I'm looking for a very specific type of component that's, it's a 3 acronym. There we go. Bo's got it. MOV. Who knows what an MOV is? I'm going to draw that down below. Who knows what an MOV is? Metal oxide variester. So I've got it. So how does a metal oxide variester work? So here's I'm going to draw a big long, this is a transmission line right here. So here's my eye. Depending on if it's a utility or who's going to draw it, I'm trying to think, I remember I used to see it on the symbol. But essentially, you're going to have it shunted to ground through that metal oxide variester. So metal oxide variesters are great because anytime there's a very large transient, so say here's my sine graph. I'm going to try to draw it freehand, so it's probably going to look pretty silly, but here's our normal voltage, right? What does it look like when we have a lightning strike? Who knows, right? It's going to fly up. It's going to do all sorts of crazy things. Our metal oxide variester, which is, we'll say that's each of these here. Here's an MOV, here's an MOV, here's an MOV. Each of those close, right? When there's a big enough voltage transient, a voltage spike, when our voltage surges in value really fast, they're going to shunt and they're going to create a path directly to ground. So we hook the primary side of our lightning arrestor, sometimes they call them LA stations. We hook the primary side to our line that we want to protect, and then we connect the bottom to ground so that if there is a massive voltage spike, when these things close, it's going to create a path for our current to go straight to ground. And as soon as this crazy voltage transient goes back to normal from our lightning strike, right? What happens? Then they open. So when they open, now our current goes back to flowing down the line. It's pretty cool. You see them in the industry a lot of times before substation transformers. If you have a really long run of lines, right, to the middle of nowhere, and then you have a small sub, you might see them right before that small sub just to protect that substation. So that's a really good exam question too. What else? Oh, wow, it's already 8:30. We're going to have trouble getting through all this. Where were we? So codes and standards. I wouldn't, out of these 3, I would say the least important is your National Electric Safety Code. Try to print, if you don't have a copy, I think you can find the table of contents for free. Chances are, look, there's 10 questions split up between all 3 of these. The majority of them, we know they're going to be the NEC, right? The P exam loves the NEC for a good reason too. It's all safety related. You can expect probably 1 or 2 questions here. They won't be terribly hard. If you've got the book, then those are guaranteed. If you're comfortable using the index and table of contents, I suggest when you come to, and you'll know it's NESC. It'll say, like, if you're not sure, like, oh man, I don't know what they're asking me, is it the NEC, is it the NESC? If it's an NESC question, it's gonna say NESC in the question, most likely. So my suggestion is, when you see it, don't stop, don't bubble or lightly bubble, just keep moving, right? You want to answer the ones that you don't have to reference first. And then when you come back to it, when you've got your time, then, okay, I know this is an NESC question. I've got my NESC. Let me look it up. Same thing for electrical shocks and burns. You got to find the right tables they're asking for. National Electric Code, be solid. Be maybe not solid, but be pretty comfortable. We know that even if it's not an NEC question, we know we can expect to see it somewhere or another. And just off the top of my head, for the NEC, I would say be very familiar with Chapter 9, Table 9. That's conductor impedance. Here, let's copy this down below. There we go. Insert text. All right, so just going off the top of my head, what I think is important. Of course, this is not an exhaustive list. I would say be really good with Chapter 9, Table 9, and that's conductor impedance. You know, that's your R and your X of L or your Z effective. Be very comfortable with conductor ampacities, right? So conductor ampacity table. Be familiar with overcurrent protection for motors, cables, transformers, or just about anything they ask for. Same thing for overloads. Know the difference between a magnetic trip. Actually, we'll say that's actually protection. Trying to think what else. And you see anything that talks about it, grounding is good, grounding rods. Since grounding, there's two other types of grounding topics, right? We got ground resistance testing, we've got system grounding, we got grounding in the NEC. There's quite a bit of overlap there. So be familiar with all things grounding. Eric, great one. I agree completely. And Eric said, be familiar with continuous versus non-continuous. Who can correct me? I want to say off the top of my head, it's 3 hours, right? Is that continuous load is 3 hours, I believe? Yes? Good. Okay. Know how to size. So continuous. Who can tell me, who knows off the top of your head? Continuous motor. What do you got to multiply your full amps by? Yep, 1.25. And is that for your, that 1.25 multiplier, is it for your breaker or is it for your conductor? Conductors. Awesome. Great job. What do we size the breaker off of? Is the breaker protecting the cable or is the breaker protecting the motor? Right? All good things to think about. What about if I've got multiple loads fed from the same conductor? Who gets multiplied by 1.25? Largest motor. Awesome. And then we just add the sum of the rest, right? So those are, off the top of my head, those are the tables that I find myself going back to the most. But remember, print out the index ahead of time. If you can copy the index from your book or find it online, print it and put it in your binder. It's so much helpful to have the index in front of you instead of having to put your arm under the page or having a bookmark and going back and forth. What else? So that's going to be 10 questions total. And again, NEC is going to be most of them. Another good one is your, can't believe I forgot it, motor full load amps. Motor full load amps and motor locked rotor current are two big ones. Make sure you know where that's at. Make sure you can get to it. Make sure you can use it. And also make sure you read the table titles. So read table titles. you're going to have, there's many different types of slightly different tables. Check for the voltage rating, power rating, temperature rating, right? Don't use ampacity for a cable that's in free air, if it's in conduit, and et cetera. So really make sure you're looking at the table titles and really interpreting the differences. All right, what else is good? Can we talk about analysis? All right, these are the good topics in my opinion. Kahina said, do we multiply three-phase continuous motor by 1.25? Yep. Essentially, you're taking that amperage, you're taking the full load amps, and you're multiplying it by 125 to find your conductor rating. So if it's a three-phase motor, that full load amps is being pulled on each of the three individual conductors serving each load or serving each phase. So yeah, you still need to make sure you increase that ampacity. So when we hit circuit analysis, these are some of my more favorite topics because in my opinion, some of you might disagree with me and you might not like this, but in my opinion, circuit analysis is easier to prepare for than the vague topics, right? Circuit analysis is a great one. Rotating machines is a great one. Electromagnetic devices is a great one. System analysis. It's easier to kind of narrow down what's going to be asked. You're still going to get theory. You're still going to get things that are unexpected, but at least you've done enough practice problems that you can at least understand the relationships just from osmosis. So three-phase circuits, who can tell me what do you think are the important ones for three-phase circuit analysis? Who can tell me directly in the chat? What are we doing when we're doing three-phase circuit analysis, right? Yes, great, Kina. Y versus delta. So be very comfortable with delta and Y, right? Be comfortable with every variation, whether delta delta, Y, delta Y delta. It's either on phasor diagrams or it's on transformer connections. But go ahead and print out, I've got those phasor diagrams of how sometimes the different combinations can do phase shifts. And surprisingly, and this caught me off guard the other night because it slipped, but when you do a delta Y, you not only have a phase shift, but you also have a magnitude shift, don't you? And I'm going to draw that out really quickly because that was something I had forgotten about. And it becomes very obvious when you draw it. So if here is, let's draw it like this. So here's one phase. So paste this really quick. We're going to say this is a delta Y step down because that's fairly common. And then let's do it in green. So green stands out. Here's our, oh, that's still purple. Okay, here's our secondary windings. Now, if our purple is our primary, and our primary is a delta configuration, and our secondary is a Y, so we're looking like this, delta to Y. This voltage right here, is that equal to our line voltage or our phase voltage? It's the phase voltage of the delta, but it's also equal to our line voltage of our transmission line, right? And if we look at a Y, right, because essentially that winding right here, each one of those windings are going to be on a phase, right? Just like on our Y, each of these windings, they're going to exist on the phases. And I hope this isn't too small. But the point I'm trying to show is right here, this is going to be our plus. I'm going to say it's our VL primary, right? So we're actually superimposing our line voltage on one phase. So it ends up doing a magnitude shift. And I'm trying to remember off the top of my head. I want to say we've got, so if this is N1 to N2, And if this is a step down, that means our N2 is smaller and our V2 is smaller. So we're gonna have N2 over N1. That's our A ratio that will result in a smaller voltage. So here's that times VL primary, right? That's just this voltage here. And I want to say it also gets divided by the square root of 3 because here's our delta winding. Check this. I need to check that on that page. I'm trying to remember off the top of my head. I believe for this configuration on the Y side, you'd also divide it by the square root of 3 because let's look at this. We're essentially superimposing a line voltage value over our phase value, right? So this is phase voltage, but this is line voltage. So just be mindful of that relationship if it does pop up on the exam, because it's pretty tricky if you're not familiar with it. And if you're not familiar with what I'm talking about here, it should be the transformer connection module, and take a look. I show each of the different combinations, and I show the phasor diagrams too. And some of the older material that I'm planning on redoing, so some of the images aren't as nice as the newer stuff, but it's definitely easy to read and well worth the references. All right, symmetrical components. Make sure, we've talked about this a bunch, but make sure you've got those diagrams for the transformers. At the very least, be able to recognize the different single phase equivalent circuits. Even better if you can set them up on your own. Look for keywords such as what is the zero sequence, or find the positive component or something like that. You're looking for those keywords. Per unit analysis. Be good with base changing, be good with picking your base values, be good with, they might give you per units, and then be very careful because you'll look at the answers. So you'll have A, B, C, D, and they usually don't, like if you look at the sample exam as a model, they don't like to put the units next to the answers all the time. They'll say, choose the correct per unit impedance below. And then here they're just going to have decimals, but it's up to you to know that they're in the units of per unit impedance. So if they give you per unit and they're asking you to solve for per unit, then you know you don't have to do what? You don't have to find your actual value by multiplying your per unit by the base. So what they'll do, sometimes that's sneaky, is they'll include this value somewhere here. And since the units aren't next to it, it's not that obvious. So just be careful. If they give you per units, just remember to check the answers. All right, what else? Phasor diagrams. Leading and lagging, by now I hope everyone's really comfortable with that. Leading versus lagging, apparent power triangles, all that good stuff. Be able to draw them out on your own really helps. Battery characteristics. Not a whole lot to talk about batteries. That module has a lot of good qualitative stuff, so be familiar with it. If you're asked to solve a problem on batteries, just treat it like a normal circuit, right? Your battery is going to have an internal impedance. You can just use circuit analysis. Batteries shouldn't be too tough. Power supplies, these can be tricky, right? Those are your diodes, your thyristors. My advice, if you don't like power supplies, and I know a lot of people don't, a great book, Wilde covers it extensively. It's one of my favorite books for a reason, but as long as you have a book that has a bunch of different power supply circuits, because even if you get good at understanding diodes, when you have 12 million diodes connected in all sorts of different ways, it's not easy to really trace it all out on the spot. So if you can flip to a power supply section in a book, match the circuit that's shown if you're not already familiar with it, and you can look at the book and look at the output voltages and output currents. I find that's really helpful. So strongly suggest you have a reference ready to go for that. Relay switches and PLCs. I think power supplies is the most important out of 5B, but relay switches and PLCs, just be ready. I know we talked about that in the last class, so I won't talk too much here. Variable speed drives, same thing. I know we covered that quite a bit. Aaron said volts per hertz. Yep. Volts per hertz are great on variable speed drives, and the newer ones even come with a volts per hertz control. But the important thing to know, of course, is that your output from your VFD is not a true AC. It mimics AC by sending pulses of different amplitudes and of different wavelengths, right? These individual wavelengths here. So by doing that, it's actually your delta, you're changing your frequency. And of course, if you don't change your volts along with it, it can have a negative effect on magnetic fields for reactive components. All right, how about what else? Rotating machines. So this tends to be where the most people have the hardest time preparing for. The reason why is rotating machines, there's so much material that could be tested on, right? Since the NCEES doesn't explicitly say, hey, we're not going to test on this, it makes it difficult to study for because there's volumes and volumes and volumes dedicated to just rotating machines. What I think is the most important, in my opinion, I wouldn't worry too much about the inductive single phase circuits. I wouldn't worry too much here. Those can be really complicated. There's many different types of models. And if they do give you one of these, chances are they're going to give you the model they want you to use. And it'll be up to you to be comfortable with. They might say they'll use the words magnetizing reactance is this, and magnetizing resistance is this, and stator resistance is this. And then in the circuit, they may just show the symbols, or they may even give you the variable, but they're not going to tell you where each of the values goes. So at the very least, be familiar with the verbiage, be able to plug them in your circuit. Because if you can plug them in your circuit, then guess what? It just becomes a really simple circuit analysis problem. Now, know your synchronous machine equivalent circuits inside and out. Sometimes you'll hear, so most books, I like Wilde again. Wilde is just a fantastic reference for motors. Wilde refers to this as induced voltage, as most motor books do, but oftentimes you'll also hear internal. So if you hear internal voltage, just think of, this is a model of inside that stator. So that's going to be the voltage before accounting for any voltage drop. Of course, load or terminal, or if you hear something like where the generator is connected, well, then that's just going to be E, your motor terminals. And be familiar with doing how to solve for current or how to set up your voltage summation formula, and know that it's going to be different for a motor or generator. So be familiar there. And again, that's circuit analysis. So if you've gotten this far comfortable with your KCL and your KVL, you should be good. Be really good with poles and frequency and speed, those equations. I wouldn't worry too much about like the really more in-depth equations. I've got them on the course as a reference on the off chance you see them, and chances are at least one of the books you're bringing is going to have them. But when it comes to motors and generators, be most familiar with the surface level stuff, because you could spend your whole life in motors and generators. Be comfortable with leading and lagging, how that applies to the circuits, what that means, how the, overexcited, underexcited, be familiar with the vocabulary for sure. Electromagnetic devices. Oh, and that's 10 questions. So you're going to have 10 questions picked out of here. So expect to see a lot of motors and generators. EMAG devices, transformers, expect to see those all over the place, either specifically talking about a transformer or, a transformer on your transmission line. Be comfortable with your transformer ratio, step up, step down. Is it single phase? Is it three phase? Am I solving for three phase? Am I solving for single phase? Be comfortable there. Reactors, of course, are just what? It's just a reactive impedance, right? You can just treat it as a conductor. And then testing, you've got your open circuit test, you've got your closed circuit test. And again, I wouldn't worry too much about really being able to solve for them. You could see a question or two, so I wouldn't discount it, but know what's the open circuit test for, what's the closed circuit test for. I find that if you draw it out, it really helps. So any questions so far up to this point? I want to make sure I pause and don't want to lose anyone if you're scratching your head. Okay, the chat's pretty quiet, so I'll go ahead and take that as a clue. Transmission and distribution. Be comfortable with voltage drop. Expect to see at least one. And this is pretty interesting. So this is one of the largest categories, right? We've got 8, but it's only 10 questions. So if you get one question on each of these, that means you only have 2 more questions to put here. Be really comfortable with power factor correction and voltage support. Expect to see a capacitor. Be familiar with, we've talked about fault current analysis. We've beat that horse quite a bit. And this is why I'm trying not to keep taking questions on fault current analysis, is since there's 10 questions in total to this entire system analysis, you're likely just to see 1 or 2 on fault current analysis. So if you like it, it'll be an easy one. If you don't like it, and don't worry about it as long as you're comfortable elsewhere. Power quality, I'd say get a good book that has, look through books. You should have a book. It's very common. They'll talk about like voltage sags or dips or transients and spikes and over frequency, under frequency. They'll typically show the graphs in the books. That's really good. Transformer connections, we talked about that. I would also include auto transformers with that. And then transmission line models, things like finding the capacitance, finding the inductance, be familiar with your GMD, your GMR, all that good stuff. Standing wave ratio, your reflection coefficient. Transmission lines is also challenging, similar to rotating machine, and the fact that it's such a large area. You could spend your entire life as a transmission line engineer or a transmission line planner. There's just a lot to know. So anytime that's true, I tend to think that they're going to test on one of the more basic ones, right? They're not going to expect every engineer to be a transmission line expert, but they will expect him or her to have at least of a background to be able to answer wisely, right? Make an educated guess. Okay, I'll pause here and take a look at the chat. I'm seeing a couple of questions come up. Tony said, when do we use Q equals sine theta or Q equals P sine theta? Tony, take a look, go to the, I'm not going to spend too much time talking about that here tonight, but go to the Power Fundamentals Bootcamp and make sure you print out that reference. And just so everyone knows, I actually updated that about 2 days ago. Someone pointed out I had a line current where I should have had phase current. So that's, I think it's like a 3 or 4 page reference. I think that's one of the most important references on the site because power formulas, if they're so simple that they're very easy to use incorrectly. I recommend all of you go ahead and reprint that out. And Tony, to answer your question, that will be pretty cut and dry when you go through that. It'll tell you right on the reference. Eric said, is that picture you drew next to 7.5% in induction motor? I thought no EO. No, you're correct. This is just a synchronous, this guy right here. And in this case, this would be a synchronous generator, the way it's being drawn, if we assume our current is going in this direction. What else? Rel asked, any good logic I need to know about contact resistance for a circuit breaker? That's a good one. Off the top of my head, I can't think of anything, but if they're asking you to solve for contact resistance, anytime I hear resistance, first thing I think of course, is Ohm's law. Keena said, the power factor is 0.85. Shall we use the Z value from table 9 without the angle value? However, if we take R and the X value, the angle should count. Okay, let's pause here and talk about that for a second because I see Shamil is talking about that too. Yes. So that's chapter 9, table 9, right? So that's NEC chapter 9, table 9. That table, you've got ignoring, we're either working in metric or imperial, right? We're either going to be in per kilometers or per feet. Even ignoring that, there's 3 things you're looking at for that table. The first is going to be your resistance per length. The second is going to be your reactance per length. And the third is going to be your effective impedance per length. These are L's too. They kind of look like ohms. Now, here's the thing. That table says, black and white, on the title, it says for a power factor of 0.85. If you read the note at the bottom of the table, it says, it gives pretty clear instructions. It says if you have a power factor of 0.85, you take your Z effective value. So if you know your L, your Z effective is ohms per L. You multiply it by your L, and you have your total resistance in ohms. So in essence, you treat your Z effective, treat it as a magnitude per your 1,000 feet or whatever unit of length you're working in. Treat it as a magnitude per your length. Now, the table is also very clear. It says if you don't have, so if it's not for, how about this? Power factor does not equal 0.85. That's the best way to show that. Then it says it pretty clear. That's when you're going to use these values, your R and your XL. And it says calculate a new Z effective. And this is the only time you'll ever see this. Whatever your power factor is, you can find the angle, right? Theta equals inverse cosine of power factor, nothing new. But now you're going to have R times cosine theta, right? Whatever your theta is corresponding to the power factor that's not 0.85, plus X sine theta. That's going to equal your Z effective. Notice what's not here. There is no J here. You're going to literally add up these two values, and that's going to be your ohms per 1,000 feet or whatever length you're working in. There's no J here. This is the only time you'll see, because what is this? This is a real component, and this is a imaginary component. It's a different, and if you read the table, it explains it, it goes more into it. It's just an approximation to get you to here. Now, here's the controversy. The controversy is a lot of the sample exams don't do this when they should. A lot of the sample exams, they'll take these R and X per L values, and they'll treat them like this. They'll just say, okay, my Z per length is R plus JX per 1,000 feet. And then they multiply this by their L to get their total impedance. They don't calculate a Z effective. Off the top of my head, I did one recently from the NCEES where they did do this. I know there's one in complex imaginary where they don't. And I want to see if there's also one in the NCEES where they don't. Even though, guess what? It's not a power factor of 0.85. Everyone, I get more emails out of this than you can imagine, and it's frustrating me too, because I gotta go. I'll tell you what, I gotta go through my sample exam, my official NCEES sample exam. If they have a problem where they don't have 0.85 power factor and they're not calculating this, then I would argue that they are technically incorrect. Since we also test on the NEC, and that table is cut and dry. It says to do that. Now, if a different author doesn't do that, then it could easily just be a foresight on that author's part. A lot of the other material out there, a lot of the other material, it's outdated. It hasn't been updated in a while. So it could just be either oversight, or maybe they don't agree with it. My personal stance is this. Since the NCEES is also testing us on the NEC, and since these values, right, we're getting it from the table, and the table itself is saying follow these directions down here. If you don't have a power factor of 0.85, well, then I'm going to take that as black and white. And if I don't have a power factor of 0.85, I'm going to follow that table, and I'm going to calculate my new ZEF. That's my personal stance. That's what I think is the most correct. I think if the NCEES accidentally didn't do that, I think they would do it by mistake. I don't think they would intentionally not follow the table instructions. And who knows? I don't have an old NEC. Maybe they didn't always have that note. And maybe the question in the sample exam wasn't updated. If that table note was updated, there's a lot of different variables. But again, I'm going to follow the instructions to the T in the note of that table, because that's where my values are coming from, that table. And that's part of what they're testing us on, right? It's part of design and engineering, right? Is being able to accurately interpret code in different situations. So that's my personal stance on that. All right, let me see. Looking at chat now. Yeah, seeing a lot of people confused. Here's the most important thing. Whatever you do, this right here, don't do this anywhere else. There's nowhere else on the electrical power PE exam where you're going to get rid of the J and add a real and imaginary component directly, right? We always want to keep these separate, and we're going to keep the J value, which is really just a 90-degree phase shift with our imaginary component. Just don't do that anywhere else, please. Don't get confused. All right, just take a minute to read the chat. Yep, it looks like there's a lot of discussion about this, and it definitely looks like a point of confusion. Eric said, I had a good question today where they didn't give me a power factor and asked for the total Z, given a cable size and a distance. Yeah, if they don't tell you, just assume it's 0.85 and just take the Z effective value. If they give you the power factor and it's 0.85, take the Z effective value. If they give you the power factor and it's not 0.85, I would err on the side of the NEC, because you could even argue that with the NCEES. So. All right. Jonathan said there's a way to use the current angle, but you arrived at a really close answer as the NEC method. Yep. A lot of good chat here. Okay. I'm scrolling down to where we were. That's interesting. Eric pointed out that the note there says to follow the 2008 NEC. I don't have the 2008 NEC, but that's still that's not that far away. I would be willing to wager that the 2008 NEC also has that instruction. If I'm not, let me know. I'd love to know. But I can tell you that I've got the 2011. The 2011 definitely has it. All right, moving on. Where were we? Getting close. Power system performance. So power flow. Power flow is kind of an odd topic, because depending on what book you have, power flow is going to be completely different, what they talk about. A neat thing is, if I have a transmission line like this, we'll put an impedance between it. So I've got, oops. So here's two transmission lines, right? If I've got, actually, let's just think of this as one transmission line. I don't want to confuse you. So how about this? This is a long conductor on a transmission line. That's much better. There's an impedance on it, right? Of course. And this is V1 and V2. And V1 is going to equal to V1 magnitude at angle V1, and V2 is going to equal angle V2. I'm sorry, magnitude V2 at angle V2. How do we know if our current is going this way or this way? Who can answer me? How do we know what power flow direction or what current flow direction? How do we know? Any takers? I bet I can show you really easy. Omar said low to high. Not necessary. I don't think necessarily. Because what about if we have equal magnitudes but different phase angles? Rel said not sure. Lee said positive to negative. And I agree with Lee. And let's think about how we can, what's an intuitive way to come to that conclusion on our own? Is this a load or a source? Who can tell me? Is this a load or a source? Right? Regardless if I've got two different voltages, right, this is a load. So does our load absorb power or does it deliver power? Easy, right? A load's going to absorb power. How about what's my polarity for my voltage drop across my load? And an easy way to think about this, if I have a source with an impedance, this is my Z, this is my source. What's my voltage across this impedance here in black? This is a VZ, my voltage drop. If my current is flowing in this direction, we're going to have plus and minus, right? Yep, exactly, Omar. So if my current is flowing from left to right through a load, what's my polarity here compared to my polarity here? Plus to minus, right? That's the way I would look at it. So here's what I would do. I would do, if this was VZ, let's make them phasors, right? Because they have magnitude and angle. I would do V1 minus V2, right? We're going from left to right. If that's positive, we know our current is flowing from VZ1 to VZ2. If V1 minus V2, if that's negative, then we know that's not true and we're actually flowing to the left, right? Because if this is negative, we can flip these around and we're going to get a positive. Does that make sense to everybody? Those kind of, when you get stuck and there's bound to be problems on Friday that you're going to be sitting in your chair, wiggling around. It's maybe the last 15 minutes on even the afternoon session. You've got a couple of problems in front of you that are going to be like this, where you're like, man, I saw a problem like that in, the course, or we talked about it, but I didn't really see one like that or from that angle. Stop and think, like, how can I figure out what do I know that can model it? Those are the kind of things that you're going to answer a handful of more problems correctly. And it's that mindset. It's being able to relate those concepts. That's what's going to get you the higher score. And you'll hear me, I'm going to say it again, but anytime I'm stuck, this is what I do. I start with Ohm's law and I'll write it down, because for me, I'm a visual person and I'm sure a lot of you are too, but by writing it down next to the problem, it's easier to see when everything's on the paper and not just, well, I've got this in my head and I'm trying to remember this. When everything's in front of you, it becomes easier. So when I'm stuck, I write Ohm's law. Next, I write my power formula. And of course, right, if we're going to be correct, these are phasors. This could be single phase. I'll write that. These are typically the two things I'm going to go back and forth with, because this gives us current division, this gives us voltage division, right? This gives us our I squared Z equations and our V squared Z equations. This gives us our P and our Q. Getting a little messy here. This also gives us power factor, right? Our impedance gives us power factor. Anytime you get stuck, right? Draw your phasor diagrams when you get stuck. Draw simple circuits. Draw everything you can to give you an edge. All right, load sharing. Pretty straightforward. I've got a pretty good module on that. It's pretty short. I'd reviewed if you haven't already. Just remember, you're going to have different MVA ratings. You're going to have different impedance ratings, all that good stuff. So know how that's going to affect the current, right? Maybe they give you the load current and they want to know the current from generator 1 or transformer 1. Maybe they give you the characteristics of both machines and they give you, the current from transformer 1, but they want to know the load current. Be able to work it any which way, up and down, whatever they give you. And a good way to practice is take a problem, solve it. And then now that you know all the variables, pretend like you don't know one of the variables and then figure out how to get there. All right, what else? Protection. We talked about this. We did a really good overview on that, but remember zones of protections, you're kind of think of it as Venn diagrams, right? If you've got a fault in a zone of protection, any breaker, right, within that zone will trip. And you also have the likelihood of having overlapping zones, right? You might have breaker 1 is in zone 1 and 2. So if you've got the middle of a Venn diagram, right, where you have two circles overlapping, then no, right, if you have a fault, it could potentially exist in more than one zone. What else? Jonathan asks, what is protection of 80% of a transmission line? You got me there. I'm not too sure. I'd have to whip out a protection book. I haven't seen that before. I hope everyone here has a ANSI device list, right, from that Wikipedia link. If you don't have it, I believe I put the link in the same module online where the recording was from that live class. Make sure you have that printed out, because that's going to be a gimme problem. They're going to say, what kind of scheme is this? It's very similar to like that practice problem on the sample exam. If you see those, you should be happy, and because it should be very easy to interpret what the right answer is. Protective relaying, same goes there. Protective devices, also a good overlap of the NEC there. We talked about that. That one class, be comfortable with TCC diagrams and curves. Same thing with coordination, right? You never want something upstream to trip for a downstream fault. You want your TCC curves to be lined up pretty properly. Michael asked, when did you talk about zones of protection? I don't remember the exact class. It's been within the last 2 or 3 weeks. I'd start with the live recordings on the online course, and I would work your way backwards and skim the agenda before you hit play. And I think look towards the bottom. I know we covered it like right at the end, but we talked about zones of protection, TCC curves, did a pretty good kind of crash course for those of us that have never kind of dived into the protection industry. So definitely a good intro. Trying to think. So let me clear this up. Got it kind of messy. This was a really good example. I'm just gonna move this on a new page. Go ahead, we'll put it right down here. So let's take one more look at these percentages. So the biggest thing I can stress is up until now. So if you figure you've got about 24 hours left, right, to really put in time, chances are you're not going to learn an entire module in a day, right? You're not going to be able to, if you haven't worked equivalent circuits yet, good luck trying to get that down in one day. It's okay to do poorly on the individual ones here, right? Your individual subcategories. If you have a couple of ones that don't go so well, it's okay. Because let's look. Electromagnetic devices made up of 6 questions. So 2 questions dedicated to transformers, 2 dedicated to reactors, 2 dedicated to testing. It's not going to be an entire test on reactors or an entire test on testing. So the biggest thing is try as best as you can, play your strengths, pass on the harder questions, come back to them. If you have to do 5 passes on that exam, that's perfectly okay. And expect to, especially for you guys and girls that are taking it for the first time, the common feedback exam after exam is, I was hitting home runs on my practice exam. I took every practice exam I could find, had multiple books, but when I sat down, I felt like I didn't know 50% of the questions on the morning exam, and my morale just tanked. You hear that experience
fairly often, and expect to be surprised. It's a very challenging test, right? We're not trying to ace it, but we are trying to pass it. So I don't want any of you to stumble just because you see, the first five, let's even talk about the extremes, the first five questions, you might not know. What happens if the first five questions are for you? They might be easy for someone else. What if they're the most challenging questions? What if it's the first 10? What if it's the first 15, right? What if half? What if the first 20 questions on that morning exam? What if you're just drawing a blank? Whatever happens, it's only going to hurt you if you let that get in your head, right? So you have to, before the exam, you have to have your plan ahead of time, right? Don't go in there swinging blind. Have your plan. It's kind of like the stock market. If you invest, they say set a plan, don't make any decisions emotionally, right? If the stock, you know, shoots up overnight, don't sell. If it crashes overnight, if there's a big drop, don't try to get out. Same thing. Have your plan, set your limits. Tell yourself ahead of time. All right, when those difficult questions, when I see them, I'm gonna expect them. You see it. Yep, that's one of the harder ones. I knew it. Okay, here we go. I'm gonna skip it. The next thing is, you guys have come a really long way. I have a bird's eye view. So for you guys, except for the live classes when we all get to participate in the live chat or on the discussion forum on the built-in course, for the most part, this is kind of like a one-on-one experience with you and me. There's about 80 of you total in the course at the moment, and I really get to see the bird's eye view. And I'm not gonna lie, the progress is tremendous. It's really neat to see, and it's really neat to see and watch it happen in the moment, seeing everyone improve. And like I said at the very beginning, I think it's actually a good sign that I'm getting the same fault current analysis questions emailed to me over and over and over. That's a good sign, because if I'm getting questions from all over the place from the same person, it's an indicator that they haven't gotten that large majority of the content down. So you guys have come a tremendous amount of way. You've put in a tremendous amount of time. I'm sure you're eager, you're anxious, you want to get this over with. When you're in the exam room, just remember how much time you've worked. If you start to feel anxious or nervous, as soon as that exam is over, you're going to go home. You're going to have the best dinner, right? You're going to feel so good because that stress is going to be off your shoulders. You're going to feel like a new person, right? You've been carrying the stress with you, this uncertainty of the outcome. You've been carrying that with you for quite a while now. Once you get through the exam, it's over, right? There's no other way to dictate how you did once the exam's over. So that's going to go away. So when you're in the exam and you're still fidgety and you're nervous, maybe even right now or in tomorrow, put that aside, right? Tell yourself, one day from now, none of this is going to matter. So right now, I need to set a plan. I need to stick with it. I need to really manage myself correctly. I need to not be up till midnight or 1 a.m. trying to learn the last minute formula. It's okay if I don't know the exact formula for this one particular problem that still feels a little uncomfortable, because I know I'm only going to get asked it maybe 1 or 2 times, and I can fail those and I can still do just fine. So trust in your abilities. You guys have come a long way. The day of the exam is not the time to doubt yourself. It's not the time to start thinking, oh man, I thought I had this down. I thought I knew this. Whatever methods you have been using to solve problems, stick to them. Trust your gut, trust your instinct. Don't be afraid of checking your work. Don't be afraid of challenging yourself when you get extra time. Trust your gut. You've built such a strong foundation that if you let it, that foundation is going to carry you through. You might not get every question right, but that foundation is going to get you to where you need to go if you let it. So I really encourage you, don't let those hard problems, don't let them mess with you, because they mess with people. When they mess with people, they doubt themselves and they stop trusting the skill set they built on, and they lose confidence. And if they lose confidence on one question, guess what? Their confidence in general goes out the window. And it's terrible, because it's really unfortunate. You spend all this time, you'd hate to have that happen to you. So it's just a word of advice. Be confident, walk into that room with your head held high. Plan on doing well. Is everyone going to pass the exam? No, of course not, right? I'm not sugarcoating this. But chances are, if you've put the time in, you should be in good shape. And if you are one of the few that unfortunately doesn't pass, which I think everyone here is going to do fine, when you're in the exam room, just know that you put in all of your effort, right? You prepared as best as you could in that particular moment. Every day you sat down to study. And if you didn't, well, then you'll know next time, right? So it's about, Jonathan said, wow, thanks, Zach. It's like any other kind of performance, or, like I go back to sports. If you guys were in, anyone who was in performance sports, or if you were a musician or anything like that, psychology is behind everything, right? The better you feel, the more you trust yourself, the better you're going to do. And you're going to feel better doing it, right? No one wants to feel bad. So it's about 9:12. I'll take a couple of last minute closing questions. If you have any particular questions, go ahead, let me know. I'll answer them now. And then after that, I will sincerely wish you all the best of luck, but I really do think you guys are going to do just great. Daniel said, I'm taking the exam in October. I'm planning on taking all this into account for going forward. Good. Okay. I'm guessing you're one of the guys that signed up early when I had that promo. That's great. Omar asked, in general, how to deal with difficult qualitative questions. Omar, go to the main website, www.electricalpereview.com. Look for an article that says, I want to say it says thoughts on the 2016 October exam and how to solve qualitative questions. Read through that article if you haven't already. But essentially, if you can come up with a relationship, then the math, you can derive yourself out of a hole if you're not familiar. Like if they say if the impedance goes up, what happens to the voltage, right? Well, we can use Ohm's law to tell us that. So you want to look at how you can combine formulas that's going to prove the relationships. And Omar, just like, let me see if I still have the drawing. Just like we talked about our CT right here, what did we do? We drew it out. Okay. Once we drew it out, we could say, okay, well, I know if this happens, this has to happen. So anytime you can draw things out, if you draw something out, it's going to bring you closer to the next step, right? It's going to think of tugging on a long rope, right? If you can draw something out, it's like pulling that rope closer to you. You're going to bring forth more just conceptual information that you know about it just by seeing it, right? Draw it out, write down the equations, look for what happens. Okay, if this variable doesn't change, only this variable changes, how are my other variables going to change? That's gonna be your best bet. And then the qualitative questions, that the tough ones are the definition ones. Save those for the end unless you're 100% sure. Save it for the end. And when you get to the end, I hope you got extra caffeine because we're going to need it, and just fly through those reference books. Pull the book that you're most comfortable with. Look through the chapters, check the index. The definition questions should be black and white, matter of fact. Just about any book, you should almost find the exact answer. But be careful because the other possible answers are going to be very close, and that's how it makes it difficult. So when you're solving a definition question, you want like an exact match. Does that answer your question? Keenan said, a motivation talk always helps. Thank you, Zach. You're most welcome, Keenan. I hope it helps. Miguel asked, do you suggest an attack plan for the test? Last time I went over it several times. Should I do anything different? Yes. Miguel, if you haven't already, I want to say the very first live class we did, so that was, I think, 7 classes ago, it was just strategy in general. The best, as far as test taking goes, every question is worth the same amount, and a wrong answer is worth the same as an incorrect answer. So, of course, don't leave any blank, even if you're randomly bubbling this. And I should say, someone here in this chat actually reminded me to point this out to the rest of the group, so I will. If you've got a minute or 2 left in either the morning session or the afternoon session, and you're trying to figure out, you're pulling your hair out trying to solve that last question, if you've got 5 or 6 questions that are still unbubbled, go ahead and just guess. If you know you don't have enough time to even go back and make an educated guess, bubble them in if you're getting, like, if you're down to a minute or so, because when they say pencils down, they mean it. When they say pencils down, if you don't put that pencil right down, you don't want to be in that situation. So don't risk not bubbling 5 questions at the expense of spending 30 seconds to solve one last difficult question. By probability wise, you're better off just trying to guess. I suggest, so going back to your plan, I suggest if you're not sure, if you can eliminate at least one answer or 2 answers and you can make an educated guess, shade it very lightly. When you shade it lightly, you're going to know to stop at that question when you go back. And if you get in a spot where there's like 30 seconds left and you just got to race to bubble in, well, then you already know what your most educated guess is anyways without having to flip to that question in the book because you already lightly shaded it. So then all you got to do is shade it in darker. And when you go back to change your mind, if you lightly shaded it, it's really easy to erase it. But yeah, the PE exam, it's all a game. And the rules of the game are get the highest number of questions right by any means necessary. So that means if the very first question is, let's talk about extremes for a second. If the first question is the hardest question on the exam, that you will not solve it, period. If you stop at question number 1 and you spend all of your time on question number 1 and you burn through your first 4 hours, you have 50% of the exam is already wrong. You already failed, right? That's an extreme. Of course, we're not going to do that. So in other words, those difficult questions, you want to protect your time because chances are if you have enough time and you have enough books, you can solve any question, right? If you were locked in I guarantee everyone in here that's listening and everyone that's going to listen after the fact, if you were locked in a room with plenty of food and water with the reference books you have now, you could get 100 on the PE exam. If you had a month or however long it took to do nothing but the PE exam with all the books, you could find every single right answer. So your time is your most valuable asset on the PE exam. And those more difficult problems, they're going to act as like a time sink, right? You want to protect your time. So the second you start going, ugh, or I don't know, or you start like tensing up, recognize that red flag, recognize it's time to move on. Lightly shade it or leave it blank. Skip it. Move to the next question. Why waste answering 4 easy questions that you know? Maybe you're the best at the NEC. Maybe you're the best at, I don't know, voltage regulation or fault current analysis, right? If you're the best at those, why would you want to get stuck? Why would you want to spend all your time on a difficult question at the expense of not answering your favorite problems, right? So the goal is the plan of attack. Find your favorite questions that you like, that you're the most comfortable with, solve them, get those right answers off the bat, then go back. The harder the question is, you shouldn't be answering the exam from the order of 1 to question 40 and then from question 41 to 80 on the afternoon. You should be answering the exam in the order of easy to difficult, and that's going to change for everyone. So I think when I took it, I probably had 5 or 6 passes on both the morning and the afternoon. And I think and I hope this will encourage you guys. My first pass, the morning exam devastated me. And my first pass, I think I'll be fairly honest, I think I only answered 50% of the exam on the morning exam. And I'm not like playing that down. I really did. And I had so many passes on the morning exam. But what's interesting is you find hints and clues on later questions that act as reminders of how to solve other questions. And it's not really, they don't do it by design. At least I don't think so. It's just the way that it works. It's such a big test. There's so many different questions. You're going to see something and you're going to go, aha, this applies to this question. That then applies to this question. I can go back. I'm going to find that and I'm going to answer it right now. It's nice. I'll say it's really nice when that works out because it's any little bit helps. It's nice when you're not pulling your hair out trying to figure out, okay, I understand the question, I just don't understand what they're telling me. They're kind of vague here. So just keep that in mind. Remember that a 3-phase machine or a 3-phase system, the ratings will always be given to you in 3-phase quantities unless they specifically state otherwise. Remember that even for a 3-phase machine or a 3-phase system, impedance in ohms is almost always going to be given in what? It's going to be given in the per phase value, right? So if you have a 3-phase system, the voltage given is going to be your line-to-line voltage, right? The current given is going to be the same current going down each of the 3 lines. The power is going to be the total 3-phase power of the system, but your impedance is going to be the impedance on each line or the impedance in each phase on the load. So that's another one people get hung up on. But stop and ask yourself, man, it's like, okay, they even tell me it's the 3-phase, but do I need my single phase equivalent circuit here to solve this? If I do I need to use, is this going to be my phase value? If you're not sure, draw it out. Telling you, draw it out. When you draw it out, those relationships are going to pop out at you. And I mean, even like these live classes, there's plenty of times here when I don't know the answer right away. And I'm not shy about that because that's the approach. That's the approach that I want to teach. That's you're arming yourself with tools, right? You don't want to memorize. You want to be able to solve. So when you draw it out and when you write down the formulas, the relationships, enough that if you see enough things in front of you, you're going to be able to put your finger on what needs to go next and, where we're going to need to go. Another thing too, also I'll add to that. I hate word problems. The way maybe this is just me, but the way my mind works, when a word problem when it types it all out, I don't understand it yet, unless it's very, very simple. If it says a motor is rated for XYZ or whatever, I will literally, I'll read the question first, and then I'll go back to the values and I'll draw, if it's a motor, I'll draw a bus, I'll draw a little M symbol, I'll draw my horsepower, I'll put my voltage right next to the bus because that's typically how you see it in the industry, like on an engineering drawing, I'll put any information I know about it. Maybe I know my full load amps. If it says a synchronous generator, yada, yada, okay, I'll draw my generator. I'll connect it to a bus. Okay, it's rated for 55 MVA. I know that's my generator's rating. Okay, it's rated for 13.8. I'll physically draw the stuff out. And when I see things grouped, I like this. When I see things grouped together, I'm going to be able to solve it 9 times out of 10. First try, no problem. But for me, I have to go from that word problem as an engineer, it doesn't make sense to me, right? I got to go from that word problem to my drawing to my answer. So really, when you get stuck, man, I'm telling you, make sure you're drawing things out. Next thing, don't forget your units. Draw your units. Don't ever fool yourself into thinking you don't have enough time to draw your diagrams and to write your units, right? You'll notice out of habit, because my biggest pet peeve, and I'll share this with you guys, my biggest pet peeve when I was taking the P exam, I hated this. S equals to VI. What is that? That could be, is that magnitude? Is that phasor? You know what I mean? It's not fair. And power relationships is actually what I struggled with the most, even though it's one of the most fundamental reasons. And it's why I love teaching it now, because it's so simple. But I don't say that to discourage anyone if you have a hard time with it. It's so simple, it actually makes it harder, which is kind of funny. But you'll notice I always try to get into the habit of drawing my vector hats, my conjugates. Is this, okay, this is single phase, so no square root 3, so that's my phase voltage, that's my phase current. You'll see me all do it every day till the cows come home. Why do I do it? Because you know how many people probably get the easy questions wrong because they forgot to draw the conjugate symbol. And because they forgot to draw the conjugate symbol, guess what happens when they go to solve for their power? They're not going to change the angle on that current. It happens all the time. When people send me, it's funny how a lot of the people that send me the most requests for help, where and I like it too. When I have time, I really enjoy it. They'll send me a picture and I'll load it up and I'll mark right on top of it. And it's funny how there's 2 types of people that I'll go, hey, careful, you missed that conjugate because you didn't write your notation. If you wrote your notation, it'd be good. 2 types of people. The first group goes, aha, oh my God, he's right. It's so much easier that way. I'm going to increase my score without having to learn anything. I'm going to increase my score just by keeping better notes. The other camp, it goes, I don't need that. I'm too good for notation, or it takes too long. Guess what happens? When the people on this side of the camp, when they send me help again, when they ask for help, their units are there, their notation, their subscripts, it's beautiful. And guess what? They hardly ever get a simple mistake wrong, right? It's just they're asking for help because they don't understand a relationship. Guess what? This camp of people, when they send me help again, 9 times out of 10, even if they don't have the relationships right, they already made a mistake somewhere in the math. So it wouldn't even matter. They never even got to the point of the right relationship. And it's these same people over and over. And, I pointed out, hey guys, be careful. You're gonna, I'm not the one taking the exam. I already passed. I already got my license. I want you guys to get your license. I can only suggest you do this. And I'll tell these people very politely. I'm sure some of you are probably even smiling right now because I know there's some of you, I won't name any names, there's some of you in this category. And I'm not saying that to pick on anybody. I'm saying that if you're on this side of the fence, guess what? The very good news is you still have time to come to this side of the fence. And this is the nice side of the fence, I promise. The water is much warmer on this side. It's quite nice. So that's about it. Any other questions? We're getting right up here on 9:30. Still got about 31 people here. Omar said, thanks for efforts. I learned a lot from webinar. I'm so glad. I have gotten so much. The feedback has been overwhelmingly positive, and it really helps. You guys can't imagine how much time and effort goes into this. I put in on average, I'm still doing 95 hours a week. I haven't had a full weekend off, and it's been about 4 or 5 months now. It's pretty crazy. It's not going to be forever. I'm still developing the course. And I don't want you guys to feel bad for me. That's not what I'm saying it. I'm just saying that, I take quality very seriously. I feel like I really have a good idea of how most of you are feeling, and I have a good idea of the traps that you might get a question wrong for. So it puts me in a really good position to point those out in the videos, to draw it out, even kind of the stuff talking about the notation. So I'm glad you get a lot out of it. It means a lot to me, and I have a lot of pride in what I do. So I really believe in doing your best at all times. So I try to make these I try to build the product that I would want to buy. So it delights me that you guys find it useful, and I'm glad it's helped you a lot. Rel said, for fault calculations, we usually have VA and impedance as given. Is there any relationships that correlates if we only have amps and maybe voltage? I feel like I'm missing a theory and kind of spitballing here. So Rel, I don't want to talk about fault current analysis too much because we covered that a lot in the past webinars. And we also talked about why we don't want to get too stuck on a nuanced topic up to this point. But I will say that as with any formula, right, as long as you have the minimum amount of formulas to solve, you can always find the other variables. So if you're in the MVA system, if you're using the MVA method, maybe they're asking you to solve for current, or maybe they're giving you current, but they're asking you to find the rating of the generator, but they give you the impedance. So there's so many different ways. There's so many different combinations of variables that they could give you and then result in asking for you to solve for that specific variable. So if you do get a question that you're not sure with, either on the exam or if you're still working a few on your own before then, write down on the paper every formula that you know related to that system, and then see how you can relate the formulas to each other. Like, I'll write down the formulas. I'll circle the one they're asking me to solve. Like, for example, V equals to I, R, if I'm solving for current, I'll circle it, put a little question mark, letting me know I have to figure out how to solve to I. So I might set this equal to I, or I might substitute another variable into R or V. It helps when you have all the formulas written out. It'll tend to guide you better into the relationship to use. But for fault current analysis, right, it's all just what? It's all your fault power contributions. Those are magnitudes, right? So any formula with your volt amp magnitude is fair game. So Three-phase magnitude is square root 3 times your I magnitude times your V magnitude. And of course, these are line values. Anything like that, V squared over Z magnitude, and that's our L. So this would be three-phase. That's fair game. Any formula, any way you can get here, right? Since that's what you're solving for. Bo said, any recommendation on snacks, drinks, caffeine to take the exam? I won't give you a recommendation to what to do. I'll give you a recommendation of what not to do. The exam day is definitely not the day to switch up your routine, right? I drink a lot of caffeine, so I brought a lot with me. What do you usually snack for, right? Personally, I don't like sugar. It makes me crash. Some people depend on sugar, right? They get hunger pangs from their change in insulin levels if they don't have sugar because they eat sugar so much. If that's the case, definitely bring some with you. Whatever your routine is, that typically has the best outcome is what you want to do. Whatever you do, bring something. You're going to be sitting down there for a long time. You're going to have plenty to do, right? You're definitely going to have plenty to do, but bring some energy snacks. And when it comes to caffeine, what's the golden rule? You can always take more, but you can't take less. Caffeine and anxiety can be related. So chances are you're already gonna have a lot of stress and anxiety in an exam. You don't want to be overly stressed out because you drank an extra, quad espresso shot, or because you downed a 5-hour energy for the first time. So just be careful. Drink some water. Miguel said, thank you for your course. I wish I'd found it the last time I took the P exam. Good luck to everyone. Yeah, best of luck to everyone. I mean it when I say I really do believe in just about all of you, and I've really seen the change over the last few months, kind of from the bird's eye view. You guys you've done such a great job. It's been pretty amazing to watch. Just, set that plan, stick to that plan. Don't let the harder questions throw you off. Expect to see them. Don't deviate from whatever path you decide to take. And 100% have faith in the abilities that you've spent a lot of time in, and you guys will do just fine. At the end of the day, it's not life or death. It's just an exam. But I know a lot of you guys want to get it. And I know a lot of you guys and girls are taking this for the second or third time. So I do know that it means a lot to everyone in here. So, all right, that's about it. Omar said, can we send email after the exam to keep you how we did in general? Yeah, definitely. Let me know how you do. I will send out emails too. Cause I want to know, I want, if I could have improved, I want to improve. So I'll definitely be sending you'll see, you guys are on my email list. You'll see, one of those mass marketing email that's just asking how you did. And I mean, feel free to keep in touch too. Be glad to keep in touch with anyone that, if I can help you in any way, even if it's not related to the PE exam, you got my email address. I'd be more than happy to correspond with you. And Bo said, this is the first time I've stuck to a strict study schedule. I think that's made a huge help. Bo, I'll call them those digest emails you've sent me shows a tremendous amount of understanding in each of those subjects. So Bo, I think you're in a really good place. All right, guys, my voice is just about done. It is our last class together. It's been an absolute pleasure working with every one of you, and I really mean that. Thank you so much for deciding to pick my course. Thank you for deciding to partner with me for the PE exam. I hope you got a tremendous amount out of it. And if there's anything I can do for you in the future, let me know. Per the email I sent out earlier today, unfortunately, I won't be, I'm about to jump into another private session in about 20 minutes here. I'm going to be literally like overlapping private sessions from now until midnight. And then a few of you got emails from me about 1 or 2 in the morning last night. And then tomorrow, as soon as my last scheduled private session ends, I'm actually hopping on a flight out of the country. So those of you that are watching this that are taking it for the October exam, everyone's access, it is going to expire. I'm not going to, it'll automatically expire when you're taking the exam. So if for any reason, if you do want to stay up late the night before, I don't advise it. But hey, you can make your own decisions. Some people work differently than others. I burn the midnight oil too from time to time. I know it's necessary sometimes. I'm not going to, the course access doesn't expire until you're actually physically in your seat. So if you need to look up something late at night, or maybe you wake up in the morning and realize you need to print a reference or something like that, that's fine too. I'm not going to yank the cord or anything like that. So you should be in good hands. But yeah, anything else? You guys all have my email address, and best of luck to every one of you. I know I'll be rooting for you guys. I'll be on a plane, very long flight. I'll be thinking about each and every one of you. So I wish you all the best. All right, guys, we're going to wrap this up and call it a class. So best of luck Friday. And I think you guys are going to do all just fine. So good night.